Right. Hello, everyone. My name is Martin Traverso. I'm a software engineer at Facebook, and I'm one of the founding members of the team that built Presto. So today I'm going to give you an overview of Presto. I'm going to briefly cover some of the motivation behind building it. I'm going to talk about the architecture, some of the main design points, and then I'm going to cover some of the things we're thinking about over the next few months. So we started building Presto almost 2 years ago, in August 2012. When we started, we were trying to solve a very specific problem. So the issue, we have this issue at Facebook. We have a lot of people, a lot of teams, data analysts, data scientists, full teams doing that kind of work, where they need to be able to look at data, get insights, and they sit all day doing that. And this is very painful for them. Traditionally, they've been using Hive for that ever since Facebook open source Hive. And as everyone knows here, Hive is not particularly fast. So until now. At least the version we use at Facebook is not fast enough. So what we tried to do when we started was to build a query engine that was optimized for people running ad hoc queries at interactive speeds. So one of the things basically the idea was to figure out what are the trade-offs we need to make if we were to start building a system. What are the trade-offs we can make to build a system that can serve queries fast or responds to queries fast, and what are the things we have to sacrifice for that? One of the choices we made in terms of query language is to stick with SQL, and specifically to be as close as possible to standard SQL. The long-term goal for Presto is to be able to integrate with third-party tools like Tableau, MicroStrategy, and et cetera. So we need to be able to support something that all other tools support. So having a custom language, custom dialect of SQL it's a no-no. Then last thing about Presto, or one of the major features about Presto, is that it's extensible. And this wasn't in the original plans, but it kind of fell out of the initial designs and architecture, and it actually has been a really, really good thing for us. So let's talk about the architecture. So how does Presto work? Presto is a pretty straightforward, traditional, parallel distributed SQL engine. There's not a lot of magic here. So like in a Presto deployment, there's a coordinator which is responsible for taking queries, and parsing them, analyzing them, figuring out how to decompose a query into a set of tasks that can be distributed across a set of machines. We call them worker nodes. So the way it goes is this. The coordinator receives a query from the client. It parses it. It does analysis. It figures out whether the query is valid SQL. Does it have references to tables and columns that exist and they have the right types? Are you invoking functions that have the right signature? Like, are you trying to compute the cosine of a string versus compute the cosine of a number, et cetera? Then it creates an execution plan that is handed off to a scheduler. The scheduler is the one that decomposes or figures out where things can run, and then sends the work to all the workers and coordinates the query as it executes. Then from the worker side, for a specific query, the workers are configured in a network of processing pipelines. So data flows from the data source through workers. They apply whatever filters, projections, aggregations. Then the data flows to the next stage in the pipeline, and which does further processing until eventually gets to the top stage of the pipeline, which is the one that serves the results to the client. So in order to do this job, Presto needs access to basically 3 pieces of information. First, it needs to know which tables, columns, and types are you dealing with. And it needs that in order to be able to analyze and plan the query. Then it needs to know, for a given table, where are the physical chunks of data. So it can do smart decisions about where to schedule the work. It tries to schedule the processing close to where the data lives, so that we can avoid cross-machine data transfers, cross-rack transfers if possible. And then finally, the workers basically need to be able to, for a given table and given chunk of data, need to be able to go and pull that data. And these abstractions are what led us down the path of extensibility. Early last year, we added the ability for extend Presto via plugins. And the first type of plugins we supported was connectors. Since we implemented plugins, connector plugins, we've seen an explosion of use cases inside Facebook that go beyond being able to query data that lives in Hive. We have connectors. We're working on a connector for MySQL. We have an internal prototype of a connector for HBase. We have some connectors for internal data stores. So with this, we can take a single Presto deployment and basically bring all those data islands together through a single SQL interface. So in order to implement a connector, it's actually pretty straightforward. You need to implement 3 APIs. One is the API that provides metadata, so it needs to be able to enumerate tables, columns, types. An API for enumerating the locations for a given table. Like think of if you're thinking in terms of Hadoop, this is similar to the input split API. And then finally, an API to serve the actual data. So given an input split, give me the stream of data, exposed as rows or as cursor and so on. It's very straightforward to implement a connector. We had someone from a different team last year implement a connector for one of their data stores that their team managed. And it took them, like 2 weeks to implement one, and then implement it, and then maybe a couple other weeks to optimize it and deploy it to production. And well, the guy was so happy that it was so easy to work with the APIs and the code that he ended up joining our team later. So since when we open sourced last year in November, we shipped with one connector for querying Hive data on CDH4 distribution. And since then, we've implemented a number of connectors for all the major variants of Hadoop, all the CDH5, Hadoop 1 and 2, and we also got some contributions from the community, like a better integration with S3, so we can access data from S3 more efficiently when using the Hive connectors. We also got a contribution for a connector for Cassandra, and we also implemented it's a simple connector that generates TPCH data, and we use it for unit testing and integration testing of Presto, and it's also useful for someone that just wants to give Presto a try without having to do a full-on deployment and integration with their data stores. Just download Presto, launch it, and then you can query from that connector. It's an in-memory generator. Connectors are not the only extension point for Presto. As of maybe a month ago, now plugins can provide implementations of additional types, and then the functions and operators that can process those types. For example, we're working on a connector that provides functions for doing training of machine learning models like SVM, et cetera. So there's a number of functions for training and scoring the machine learning models, and data types that represent, for example, an SVM, et cetera. And these are all encapsulated in a plugin, so if that's what people are interested in, they can deploy that plugin and they get access to those functions. And then third-party plugins can obviously provide additional functions and additional data types. So big question is Presto fast? And the answer, any self-respecting engineer would say, is it depends. So one of the things we've noticed throughout the history of Presto is that the performance is very sensitive to how fast we can get data out of the data stores and how fast we can decode it, decompress it, et cetera. So if you ignore that part of the equation, then the Presto engine is actually pretty fast. These are some of the factors that contribute to that. So let's look over them. So one important thing is that one of the major killers of latency is I/O. So you want to avoid disk access and having to touch disk as much as possible in a low latency engine. So unlike MapReduce, which needs to persist and checkpoint the intermediate results after each map step, read step, et cetera, in Presto, we don't do that. Once we read the data from the original data source, the data flows through the system through the pipelines and is buffered in memory as necessary. So that reduces a whole layer of latency latency When we started experimenting with Presto, one of the things we noticed, and this, I know people may have run this into this problem too, but it's a particular problematic issue at Facebook, which we have tables that have thousands of partitions and hundreds of thousands of files on HDFS to contain the data for those tables. So one of the problems is that if you're running a query, you need to figure out what are all the files that I'm going to need to be able to schedule across workers, for workers to access and process. And if you do that in advance, I mean up front, when you're planning the query, it can take a really long time. We've seen cases where the minimum time it takes to execute some very simple queries is in the order of tens of seconds, which is not acceptable for interactive queries. And people are sitting in front of the CLI and typing queries. So with that observation, we end up designing the execution and scheduling engine so that we can pipeline the execution together with the planning of the query. So as soon as we start looking at the available partitions and splits, and we see we discover some files, we start executing the query. So for simple queries, like for example, say you're doing a select, start from some table, limit 10, because you want to see what data is in that table. What's going to happen is Presto will start executing. We'll start enumerating the files. It will discover a few input chunks. It will say, workers start processing. The worker's going to say, oh, I produced 10 rows, the 10 rows you needed. And the coordinator is going to see that the query is finished, effectively. And it's going to tear down the entire execution without ever touching or having to enumerate all the partitions and all the splits. So for small queries or queries that don't need to look at the entire data set, this is a massive win. We're able to take queries that we're taking at a minimum of, let's say, 40 seconds down to a few hundred milliseconds just with this optimization. So the last three items relate to how efficient is the engine. Or how do you build an engine that is efficient in terms of CPU processing? And Presto is written in Java, so this is mostly a question of getting out of the way of the JVM and letting it do its job. So basically, one of the things we try to do is be very careful about what happens in the inner loop of the computation. Try to do as little work as possible, avoid memory allocations, avoid code structures that make it hard for the VM to do inline optimizations, et cetera. For example, if you have complex hierarchies of objects with virtual method calls, those end up being not optimizable by the VM as good as well as if they were like non-virtual calls that could be inline and so on. So we are very careful about what we do in the inner loops. One other thing we do is we generate bytecode for parts of the query. We take a filter, a projection, whatever we can package it into a single piece of processing, and we say, we convert it down to bytecode and tell the VM, OK, go and run this and optimize it. This lets the VM run through all its optimizations, and we get out of the way of trying to interpret expressions and so on. So let's talk a bit about what's next. And I'm going to cover 4 different areas. These are not exhaustive. It's just kind of the direction of where we're going. And priorities will obviously change as we get closer to working on them. So the first thing is we want to extend the language to support additional features. SQL is a very rich language, and we only support it's a sizable fraction, but it's not a complete implementation. So specifically, we want to be able to support non-scalar types like structures, maps, and lists, and obviously in the way SQL interprets them, and have the proper implementation for all the language features that operate on those types, like being able to unnest, do lateral joins, etc. There's a bunch of other features that are kind of in our roadmap, like supporting views, being able to create views within Presto and then taking advantage of them. being able to run scalar subqueries. We support some forms of scalar subqueries, but it's not a very extensive implementation, like correlated subqueries, et cetera. And then we want to be able to run all the queries in TPC-DS benchmarks, which means we have to add better support for some analytic window functions. We have some very simplistic implementations, so you can do some things, but we need to extend that. We're also going to be doing some work in the execution engine, and this is mostly about removing some limitations. Like today, if you're doing a join and the small size of the join doesn't fit in a single machine, the query won't be able to run. I mean, Presto will detect that and will fail the query. So we're going to be working on expanding the types of queries we can run, so we can take advantage of the entire distributed memory in the cluster. If the data is, we know the data is co-distributed or co-partitioned, when you're doing a join, we can push down some of those joins into the individual fragments, so we can avoid having to load all the data in memory. So these are a bunch of optimizations we're going to be looking at. And then we're also going to be looking at like strategies for doing better balancing the work that Presto does, but via work stealing or some ways of adapting the plans as the query executes. This can also help, or I'm sure also help with being able to support recovery. Like if one node dies in the middle of the execution of the query, we can recover where it left off. This is very hard to do in general because we support pipelining and streaming throughout the entire execution engine. So there's only a few sets of places where we can do that, but it can help for a bunch of cases where queries just fail and it's trivial to recover, or we want to be able to move work between machines so we can balance the work. Then this is one of the most important features people have been asking for. We've heard from people inside Facebook. We've heard from people outside. Everyone's asking, like, do we have what's the story around being able to integrate with tools like MicroStrategy, Tableau, et cetera. Those tools require ODBC to be able to talk to Presto. So what we're going to be doing, actually, we have someone in the team working on this right now, is an implementation of an ODBC driver specifically designed to be able to talk to Presto. And so obviously the idea is to be able to support all the common platforms, and it's going to be open source as part of the Presto project, so it's going to be Apache licensed. And so the idea is people need to be able to query, or they want to query Presto through Tableau or MicroStrategy, and this enables them to do that. Another area we're going to be working on is performance, of course. I mean, this is something that we look at continuously. There's a bunch of micro optimizations we're going to be doing over the next few months. But there's also some areas, like big areas we're exploring. Like I mentioned before, that the performance of Presto is in many cases defined by how fast we can get data from the stores, how fast we can decompress it, decode it, et cetera. And there are some use cases that are hard to pull off if you're trying to access data from Hive, either because the formats are not efficient, they require a lot of work just to be able to get the data into the Presto process. Maybe the format and the way Hive deals with data doesn't allow you to do more granular updates of the like insertions, et cetera. So there are some things that you won't be able to do when sitting on top of Hive. So what we're thinking is we're going to be implementing a native store that sits inside of the workers and very possibly even inside the Presto process, so that we can avoid the cross-process barrier when trying to access data. And we're going to look at formats that are optimized for the way the Presto engine looks at data, needs to be able to process it, so we avoid all the decoding, decompression steps as much as possible. So the usual use cases for this are those where we have people that want to feed data into the system and be able to query it very quickly after the data went in. And for example, with Hive, and especially with the way we use it at Facebook, you get data into Hive and on an hourly basis, or on a daily basis. So if you put some data in, you're not going to be able to query it until tomorrow. And this is not acceptable. So this is one of the things we're targeting. The other cases we have data sets that are queried over and over again, especially like if you think about how like people normally use Hive, they insert data, maybe they partition it by day, and then queries end up looking at the most recent days. And that data, and they keep looking at it over and over again, and that's, if you could take advantage of caching or do something with the way you are storing and representing that data, you can speed up the access for those hot data sets. So we had a prototype from a while ago. We're going to resurrect the prototype, and we're going to start investing in this probably over the next half. So Presto is open source. We open sourced last year in November. We've seen a lot of interest from the community. So we had some contributions, as I mentioned before. And all the development is in the open. We use GitHub, and all pull requests, all issues, etc., are all registered in GitHub. So if you guys want to see what's going on, you just can go there. We try to release every 1 to 2 weeks. And the way we do this is we look at what's on trunk. We run tests every night. We deploy the whatever's on trunk into a bunch of clusters inside Presto, and then inside Facebook, and then we run a suite of queries against the test clusters and against production. We compare the results, make sure that there's no correctness, bugs, etc. We do the same thing for performance to make sure there are no big regressions. And then when we're comfortable, we cut a release, and then we deploy that to production. So we run the exact software that is on the open source site with some plugins for additional data sources that we have internally. So we don't keep an internal fork and then eventually every now and then do code drops. It's whatever's on trunk is what we're looking at, and we're going to be running over maybe in the next couple of weeks or so. So with that, I'd like to open up for questions. So which project is abandoned?
It's Hive for multi-data centers.
I'm actually not familiar. I mean, so the question is, there's a project in Facebook to be able to support Hive across multiple data centers. So potentially Presto could be used to query across all the Hive installations. And then you're asking whether the Hive part is abandoned. No, I mean, internally, we run multiple Hive deployments because we can't hold all the data I mean, we have a cluster that is a couple hundred petabytes or so. We can't hold all the data in a single physical cluster, so we have to partition across. And we have tools that allow us to move things around from data center to data center and so on. So there's a bunch of metadata management and data warehouse management that happens. Presto definitely could support that. Right now, we don't run it that way, specifically because Presto doesn't know, it doesn't have, it's not smart enough to be able to decide how to push things down into different clusters. So if you're joining against data in one cluster versus another cluster, do you run everything in one cluster and ship the data over? Do you do the other way around? How much data are you going to transfer, et cetera? So
they were going to run the Hive query where the data is, even if it's on a different data set. So in other words, the query goes to the data rather than bringing the data.
Yeah, that we do, and that's so. The question is whether for the Hive with multiple data centers, we allow. So you submit a query, and the query runs where the data lives, and that's exactly how it works. We have tools that say I want to connect to my data set, and you run the query, and it gets routed to the right cluster. It's not very complicated.
What I'm talking about, this is your link, facebook.com.
Yeah.
And
Yeah.
so I'll send you.
Yeah. So.
Yeah. Is there
Yes, I'll let Dane take that one. He's been doing a lot of work on, Dane is one of the other members of the team. He's been doing a lot of work on data formats and benchmarking and so on. You can do that.
Is this mic? Can you turn this? All right. Well, I'll just talk really loud then. So today, right now, if you download Presto, you should be using RC binary. It is by far the fastest format. Lately, since Hive 13 was released, I've been working on new benchmarks for the various file formats, and specifically, I've been working on the new ORC format, and in my benchmarks, I can get the new ORC format to be actually significantly faster than our current fastest, which is RC binary. It's on average about 5x faster in our micro benchmarks. We'll see how that translates into real query execution. So right now it's RC binary. When we land the new reader, which does ORC vectorize with the row skipping, with a structural type support in it, et cetera, that will go in soonish, I think, next few weeks. And then that will be by far the winner. And there's a whole bunch of new tricks. I think ORC is definitely going to be the best format. I've done a bunch of looking at Parquet. The Parquet performance on Hive is really, really not good. It's not the format, it's the reader. Like the reader code needs like some serious love to be able to perform as good as ORC does out of the box today. And I think we could do more work in Presto to make Parquet faster if like people really wanted it. But in general, like when we suggest people use a format, they use it, and like that works good for them. So it'll probably be ORC, because at Facebook we run a fork of ORC called Dwarf, which is also open source, and it has it has different properties, very similar format. So I'm writing the one for ORC. Once I'm done with that, I'll port that over to Dwarf, and that'll run good for both of us. But it's going to be ORC moving forward, but RC binary today. Does that answer whoever's question that was? Okay.
Is there any limitations of the SQL Presto supports now?
So,
of course.
Yeah, so the question is whether there are any limitations on the SQL that Presto supports. So in terms of language, yes, of course. There's like, for example, for analytic window functions, we only support a few, like row num, count, etc. We don't support lead, lag, and all the other ones that you would normally be interested in. This is part of the things that we're going to be looking at over the next few months. We don't support correlated subqueries, for instance. You can do certain types of subquery where you can say select where from table, etc., where something in a subquery, but it cannot be correlated. We don't support scalar subqueries in like in the select clause, etc. There's a bunch of small things that we don't support right now that we want to be able to do in the future. So one of the big things that people have been asking for, especially at Facebook, because we have data that's stored using arrays and maps and structs in Hive, is support for unnest and lateral view or equivalent. So that's also stuff we're going to be implementing. So the question is, what about insert? Right now, we support simple queries, and we can create tables from a select. You can say create table as select from some queries. So we basically write back to through the connector APIs. So if a connector supports writing back, you can do that. We're definitely interested in supporting insert, so you can insert just a set of rows if you know what they are, or even stream data from the client. We'll see what the implementation looks like. There's some people in the community looking at that. We're engaging with them to do that. So the question is are UDFs supported? And I guess the question there is, what do you mean by UDFs? Because Presto today supports pluggable functions. So you can write a plugin, you can deploy a plugin with the cluster, and you can basically implement whatever you want. If the question is whether users can do it, can say, I have this jar file and I want to install it in Presto, Right now, we don't support that. The core of the system allows for that, but we don't support it. And we are eventually going to be able to, or users are going to be eventually be able to do that. But the question of whether we run the, yeah. Right. Oh, so the question is whether Presto can run Hive UDFs. And right now it can't, and it's one of the things I've been thinking about doing, implementing a bridge between the way Presto expects UDF to be laid out to how they work in Hive. So it should be easy to, you should be able to deploy a jar and then run queries using those UDFs. It may not be the most efficient because the APIs for UDFs in Hive are not the most straightforward, but at least we want to be able to support that. So actually, this is an idea we've been toying with. There are no formal plans to implement that, so if anyone from the community wants to contribute that, that would be a great addition.
What workloads are you finding Presto is working really, really well for right now?
So the question is, what workloads are we finding Presto to be able to work with? Ideal. Well, based on the limitations that we have today, so any queries where you're doing aggregations, filters, projections, and joins with small data sets, that's where it works very well. Sorry, joining to a small data set. I mean, because Presto executes joins as it's basically a broadcast hash join. So you take the small side, send it to all the workers where you're going to be doing the join, and then we stream over the large table and probe on the hash. As long as that small table or side of the query fits in memory, then you can do that. And I mean, it depends. I mean, it's also hard to say because we also support all these different connectors, and there are workloads that are good for some connectors but not for others, and there are use cases that are good for some connectors and not for others. Yeah, so one of the projects we're working on right now is integrate Presto with sharded MySQL. So there's a connector we've been working on that allows you to say, I have all these MySQL instances, the data is laid out in this manner across all those instances, and we can run queries against that. And because it's MySQL, if you're inserting data into MySQL, which allows for granular updates and so on, we can query that data very quickly after it makes it into those systems. Which again, it's not something you would normally be able to do with Hive, but you can do it with MySQL because it supports granular inserts and so on. So the question is, if the join reuses the data set, is Presto able to figure it out, or does the condition need to be specified in the join condition? Well, it's not a simple question to answer. So Presto does a bunch of optimizations for joins, and like in terms of manipulating the shape of the query to be able to reduce the data set. For example, we push filters through the join. If you have a filter on top of the join, and then we try to push it through the join so that we reduce the size of the data that comes in. If, for example, one of the optimizations we do is, let's say you're joining on field ID, and then on one side of the join, you're saying where ID in some range, but you don't do that on the other side. We push that filter all the way through the join and into the other side so we can reduce the size of the other data set coming in. If the table is partitioned by the join key, we also take advantage of that, and we can prune partitions on the other side based on the partitions that you see that make part of the criteria, match the criteria for one side. I mean, there's a lot of work to be done in this space. I mean, this is just the beginning. So. So the question is, what is the performance of Presto, and whether we have done comparisons with other SQL and Hadoop systems. We did some early benchmarks last year, but we haven't looked at that since then. I mean, I don't really know what like, if you did an apples-to-apples comparison in a realistic scenario based on the workloads that you're going to be dealing with, I don't know. We haven't been looking at that. We have, so the question is, do we have indexing support? And we have, recently we added an API to the connector, APIs to be able to do lookup. So if the connector supports accessing data by key, Presto can take advantage of that, and it can do batch lookups on that through that API. So if you have, let's say you have a table that is, you're joining a big table, but you have some filter criteria that makes it very selective based on the join keys, and you're joining against another huge table that supports an index based on those keys, you can, Presto can take advantage of the index, and instead of trying to build a hash table out of that side, it does the lookups just for the keys you want. So it's very primitive, and we did it for one of the use cases that we have internally, and it works very well for that. It's not great if you're going to end up asking for all the fields or all the rows in the other side because your query is not selective enough. So. So the question is, so Presto is for interactive queries, but do we use it for long-running queries in Facebook? So we optimize for interactive queries, and people end up using it for all sorts of things. Some people end up running queries that take an hour, 2 hours, which is interesting, because if you compare that same query against what it would take in Hive, it would be like a 10-hour query in Hive or a 20-hour query in Hive. So there's definitely an advantage there. Now, having said that, because we're not focusing on like reliability and be able to recover when things fail, the longer you run a query, the bigger the chances are that one node dies and you have to restart your query. So we don't encourage people to run that kinds of queries yet, because we're not focusing on that use case. We are planning to do so, yeah, yes. That's kind of in the long-term vision of Presto. Yeah. So the question is whether there's anything on the roadmap to be able to do cardinality estimation or cost-based planning. Definitely. So the current planning engine is very, very simplistic. It's just a bunch of rules. They create. So first, we create a simple relational operator tree, and then we do a bunch of transformations to come up with what the tree that we're going to execute. We are thinking of going towards a planning model where we can do more explorative. Like if you look at how Optic does it and other traditional engines do it, where you start with a plan, and then you evaluate, you explore the possible transformations until you find one that is more efficient. And in that, there's obviously being able to take advantage of statistics, being able to take advantage of heuristics of based on things that we estimate are better or worse, and so on. Correct. There's no reordering joins, yeah. Oh, yeah, actually, point that Dane asked me to mention is that we're also thinking of ways to make the execution adaptive, and the plan basically kind of fuse the execution with the planning, so that we can start maybe with a not so optimal plan, and then as we run the query, figure out that, oh, maybe that wasn't a good decision, and then shift things around in the middle of the execution so that we can continue with a better plan. And that's kind of blue sky kind of idea, but we eventually want to get there if possible.
So Facebook is also using Vertica, right? It looks like Presto is pretty similar to the functionality that Vertica provides. So what's the strategy in Facebook, like moving to different products? Are we for similar?
Yeah, so the question is, at Facebook, we also use Vertica, and it looks like Presto is very similar in functionality compared to Vertica. And yes, and whether at any, like, how do we determine whether we run things in Vertica or Presto and so on? Well, Vertica is being used for a very specific use case, like mostly for business intelligence, analytics, and like Vertica, obviously, because it's a lot more mature, it supports features that Presto doesn't support yet. So we don't have so we don't have all the data. We can't take all the data in Hive and put it in Vertica. Like Vertica is not designed to do that. So you're limited by that. So typically when people use Vertica, they pick a few well-chosen and transformed data sets and load them in because they want to do special analytics that they cannot do in Presto. Otherwise, Presto is the right thing to use. The other thing is that Presto doesn't support ODUC yet. So if you want to connect it to Tableau, like there's no option there. Some people rely on being able to do that, so they use Vertica for it. Sorry, can you speak up? So the question is whether Presto supports tables that use Avro as a format. I think Dane has been playing with that or tried it a while ago.
Yeah, the answer is no, and I can talk to you afterwards. The Avro format is particularly annoying to work with. It's a long story. My quick opinion is I don't think it was actually designed to work well with Hive at all. Like it's difficult to work with the way it's shaped, and we've had a couple of users who are trying to use it, and once you start digging into it, it's like it actually only supports a few data types, so you're going to be much better off switching to something else. It's also if you switch to Orc, it's faster, smaller, cheaper to store, etc. So like I would say anyone using Avro today should be looking at switching to either Orc or Parquet. Like I think Avro's like on the list of formats that I don't think anyone's going to use anymore. That said, I did look at it, and I can't remember. I think I got it working, but you know, if you really need it, come talk to me, and I can probably pull up my patches and maybe get it working. But you should really pick a new format.
All right, we're out of time. If you have further questions, we'll be around. Thank you.